Hello all, welcome to the VoIP Traffic Analysis course on Pentester Academy. Now in this course, we look at how SIP authorization can be attacked and it is possible to recover the password at times. So we've already looked at the basics of SIP authorization, and let's actually open up a PCAP file. Called registrationsuccess.pcap. This should be available for download with this video. Okay, so what we've done in this case is we've just isolated a single registration attempt, and that attempt has been successful. So if you notice, the client sends the server a SIP register message. The server responds back with an unauthorized, and this contains the www authenticate header, and we can clearly see this is digest authentication. Some parameters are sent, and then the client responds back to the server with the authorization response. We can see that here, and we can see that after that the server sends back a success. And the whole idea here is to go ahead and and basically what this means is that the authentication succeeded, the authorization succeeded, right? So what we want to do is to analyze this, look at the process, and see how an attacker can go about cracking the client's password if he were to go ahead and manage to sniff this exchange. So let's actually jog our memory a bit. And if you remember, at the very beginning of the course, we had talked about SIP authorization. And what we understood was this was really a multi-step MD5 hash calculation where finally a response digest is sent. So let's actually look at the different steps. So we see that the very first step is an MD5 hash which is created using the username, the realm, and the password. So let's actually find the username, the realm in the packet. So we are going to be looking at the client's response to the server. And what you'd actually find is the username is 1111. And after that, the next thing to be found is the realm. And the realm was actually sent in the unauthorized message. Here it is. Asterisk, and the client actually sends back the realm in its response as well. Okay, so an attacker could pick it up from either one of these places. Now the password is unknown for an attacker. The client's password actually was abc_123321. So the first step in calculating this MD5 hash is to go ahead and concatenate these. So username :realm : password, we can see that 1111 : asterisk : the password, and then calculate an MD5 checksum for this. So which turns out to be this value here, right? Now, the next step is to calculate the second MD5, which uses the method and the digest URI. So the method is register and the digest URI is really sip : followed by the IP address. So if we actually go in here, we can see that the authentication URI is actually sent here with the client's message sip : 192.168.20.130, the server's IP address. And the method is register, of course, and that's something we can also confirm from the request line. We can see the method is register. Okay, great. So now this hash is also calculated by concatenating both of these. Finally, we take the two hashes we've already calculated and then take the nonce count, the nonce, the C nonce and QOP, concatenate all of them and take the final MD5 hash, which is the response digest. So if you look at it, we take the first hash which we calculated, which is right here, followed by the value of the nonce. So if we go in here, you can see that here is the nonce value. Oops. Here is the nonce value, which is what we've taken. Colon the nonce count. This is also there in the packet. So we can see that here is the nonce count. Followed by the C nonce, then the QOP. So here is the C nonce value. Here is the QOP value. Now some of these were sent by the server already. For example, we can see QOP was sent, the nonce value was all sent by the server. The client is just reflecting it back in its response. So the server can, match and figure out this digest response is corresponding to which, kind of challenge the server threw to the client, right? Okay, followed by the QOP, which is auth, and then we concatenate all of that, including #2, take an MD5 checksum, this value comes out, and this is the digest response. So if you look at it, this is really this value right here, digest authentication response. Now, once the server receives this, it recalculates the same thing. If the values match, the server knows that this is actually the authorized client, and then authorization succeeds. Fantastic. So now if you look at the whole process, if an attacker were sniffing and monitoring the network, then apart from the password, he can pretty much go ahead and sniff everything in this exchange, right? So this is really where SIP cracking processes come in. And as you can imagine, because the attacker knows the final digest response, he could end up using a word list or a brute forcing technique if he knows probably the list of characters that the clients use. And then he can generate a large list of possibilities and try each one of them out, plug in the password, calculate MD5 recalculate this hash, and then see if the digest response matches. If it does, that's the password. If it doesn't, go back, try something new. Okay, so the tools we are going to use in this video for this process are sipdump and sipcrack. And for this video, just install these two tools, sipcrack and crunch. Crunch allows us to create arbitrary word lists using different combination of letters. So in my case, it's already pre-installed. Now the first thing I'm going to do is create the word list using crunch. So I'm going to use the time command so that we can roughly time how much time it takes. And before that, let's actually run crunch without arguments. We see that crunch takes in a minimum, a maximum, and of course the options, which basically are the character set. So I'm going to say crunch, and really the character set I want to give is ABC123. So along with underscore, because we know that the password in this case is ABC1_1233321, right? Of course, I am forcibly generating a large word list which will contain the password. If the word list doesn't contain the password, this cracking will not work. Now, the important thing to note is why this attack is still potent is really two reasons. One is that because the password is typically set by a human being, there is a possibility that this is not something which was strongly selected. B, in today's world of cloud computing and GPU clusters and whatnot, it is much more easier even for a lone attacker to try out trillions of combinations and go ahead and attack such a scenario, right? And this is what makes these attacks more and more practical in today's world. Even though there is no guarantee, of course, if the password doesn't exist in your brute force set or in your dictionary, then you will still fail to crack, right? It's important to keep that in mind. So let's go back in here. So I'm going to give the character set. So we have 3, 2, and 1. We have A, C, B, and underscore, right? Now this is 7 characters followed by, if you look at the length of the password, it's 10 characters. So I'm going to tell crunch, generate all 10 character words using the character set 321 ACB underscore, right? I'm going to pipe this to a file called word list. Let's actually time this as well. Now keep in mind I'm using this inside a VM, so it is assumed that this is going to be a bit slower. So we can actually see that these are the number of possibilities, so which is roughly 282,475,249, right? If I'm reading this correct. And you can see roughly the size is going to be around 2 gigs. So let's wait for this. So once Crunch generates the word list, we'll use the word list along with a tool called sipcrack to crack these hashes. Now, of course, we also need the hash from the PCAP in a format which sipcrack can actually use. So the way to do that, so I just hope we generated the whole word list. I'm just going to do a very simple cat word list word count -L just to make sure. May have hit a control C or a T. Okay, now this is good. So it roughly took a minute for Crunch to go ahead and get this done. So now the first step is, of course, to extract the hashes from the PCAP into a file, and we can do that using a tool called sipdump. So sipdump takes in options. So we can go ahead and give it the PCAP file, which is registration success, followed by the dump file name. I'm just going to call it dump. And it automatically says it dumped one login information. And if you look at the dump file, so it looks like I actually tested this before I do the video. So we already have one. I'm going to remove the file, redo the command again. You should basically only have one entry in there. There we go. Right? So all of these hashes and all these values, nonce, etc., you can actually see that sipdump has ripped out of the packet and gone ahead and put this into the dump file. Now, the companion tool I'm going to run is sipcrack. And sipcrack can now take this dump file hashes, all of this inside, and then try out every possibility with whatever word list we are giving. If you notice, it also has an option for std in, so you could have gone ahead and piped the output of Crunch directly to it. So I'm going to do, let's actually time this as well. Sipdump, and we have to give the word list followed by the dump file. And let's allow this to run. Did I do something wrong? Oh, my bad. I should have run sipcrack. Crazy. So I'm going to time this. Sipcrack. Word list. And finally the dump file. Let's hit enter, and it'll ask you, there's only one entry in there. If there are multiple entries, you can select whichever one you want. And now it begins the cracking process by going through the word list step by step, picking up a word. And once it picks up any individual word, it actually goes in here and does all of this, creates the response digest, and checks it with the expected digest, which is already there in the hash file. If both of them match, then it knows that it has the right password. If they don't, it goes and picks up the next word. So I'm going to pause the video here briefly. This might actually take a minute or two. If this was a live class, I would have gone ahead and probably added some filler information and talked with you, but I'm just going to pause. Okay, there you go, a minute and a half roughly. And we can see that the password cracked is abc underscore 103321. And if you now look at the dump file, you'll actually see that the password was added automatically at the very end, right? And if you try to run sipcrack once again with all the same parameters, it'll pretty much just immediately exit and say it's already cracked it, right? Fantastic. Now the key thing to remember is, of course, this is not a cryptographic vulnerability. This is really just possible if you end up having that password in the word list or in your brute force, possibilities. But as I said, this is becoming more and more practical because of cloud computing and the fact that human beings still pretty much set extremely easy to guess passwords. And for an attacker, if he's actually monitoring a whole network, all he needs is for one user to make a mistake, and then he would end up getting access to the user's VoIP account, right? Okay, cool. So now in the next video, and the slides actually contain all of these steps. In the next video, what we're going to do is look at how we can use Hashcat to actually run this on a Windows machine. That's all for this video. Thank you.